Hello students, myself Sumangla Birada. In the last video we already discussed about some of the binary operations. Now in this video let's see about additional relational operations. So aggregate functions and grouping. So along with the relational operations, okay, we can go for the that is set theory operations, unary operation and binary operations. Along with that we can also go for this aggregate functions. Aggregate functions are performing some operations as a functions that is sum, average, maximum and minimum and the count. So now this is the syntax if you want to go for aggregate functions and grouping. So you are using the one of the notation as a operator. This is the F, that is what we call as a script F. Script F is the operator used for aggregate function, and syntax of this one is first you have to specify if you want to perform the aggregate functions for the group of the attributes. Those grouping attributes first you have to specify here. Next is the script operator. Next is the function list. What are the functions you want to perform? So those function list you have to specify here, and which relation you want to perform, that relation name you have to specify here. Grouping attributes is a list of attributes of the relation. What are the relation is specified in R node? That relation list of attributes you have to specify as a grouping of attributes. Function list is having the combination of function and attributes here. Function is, it may be the any one of this function. So that is sum, average, maximum, minimum, count. Okay, any among this one you can take as a function, or multiple functions also if you want. Yes, you can specify multiple functions also. Next is attribute, is the attribute of the relation specified by R here. Okay, so this is the syntax of the aggregate function here. Let's take one example. Now I want to apply that count. Count is what here? The script is what? Now you want to use the aggregate function. This is the script F is the operator. Next you have to specify the functions. Count and average are the functions. So for which attribute you want to apply this function, that attribute name you have to specify next here. Count, this one you want to apply for the SSN, and average, this function you want to apply for the salary. So these are the attributes of which relation? These are the attributes of the employee table. So this is your employee table, and now you want to count number of employees by what? By the SSN. So in SSN how many tuples are there? That one it counts. Count means it counts 1, 2, 3, 4, 5, 6, 7, 8. So for the count result is 8 here. Next is salary, average salary. So all the tuples you are having the salary, no? So it add up all the salaries and it divides by the 8. That is what we'll get as the average, and that average salary you are getting here. So this is the output of this aggregate function. It counts number of employees, how many employees works for that particular department. Those employees count as a 8 result, and average salary of the all the employees. This is your result here. So this is how aggregate function works here. Next, one more thing you remember, usually if you want to use the any operations, then it may be union or it may be the join operation, then what happens, duplicate tuples are eliminated, okay, in union operation or in the join operation. But here in the aggregate function, it duplicate tuples are not eliminated, okay. If you are having the duplicate tuples, those tuples also it consider as a version, okay, as a tuple. It doesn't remove such type of the tuples here. It consider that one also one as one of the tuple. Next is grouping. As I told, if you want to group, then also you are using the same operator, as that is the script operator, and by which attribute you want to group, that attribute name you have to specify here. And next is script F and functions. What are the functions? For which attribute you want to specify the functions, and from which table or which relation you want to specify, that relation name you have to take here. I'll take the same example here. Earlier you are calculated what? You are found the function as a number of employees and also average salary of the employees. Now you want to group according to some attribute here. So what is that? DNO. You want to group the attributes. Means that is very simple. How many employees works for department number 5? Those employees you want to make as a one group, and you want to find the all those employees belongs to department number 5, and you have to count those employees here. Next, for department number 4, how many employees are there? That one you have to make as a one group. And how many tuples comes under in department number 4? That is number employees will come. That one you have to take as a result here. Next is number of employees comes under in department number 5 here. So you want to group the tuples according to department number 5. So this is the result of this grouping here. First it group the tuples, department number 5 as a group 1, and how many tuples are there? That employees it counts and average salary of those employees. Next, department number 4, how many tuples are there? That one it makes as a one group and it counts the number of tuples and it retrieves the average salary of those. In department number 1, number of employees and their average salary. Yes, same script F you can also use for to perform some functions, and also you can perform according to grouping attributes. Same thing, I am taken the example. So here this is the your script, okay, F, and you are performing the count and average functions for based on the group here. Here I used this operator. As this operator is what? This is the row operator, and this row operator you are using for which purpose? As to rename. Actual relation name is employee. That one I renamed as a new name as a R here. And actual attributes are DNO, count SSN, average salary here. But I renamed those attributes as a new attributes in new relation, DNO, number of employees, and average salary. So after applying this script, okay, aggregate function, what are the result you will get? No, that result goes and stores in a new relation. For that relation you can give the new name. Okay, that is the row operator you can use to give the new name for the okay old relation. So this is about the aggregate functions and the grouping here. Is it clear now? Okay. Next we'll go for recursive closure operations. It is applied to a recursive relationship between tuples of the same type, such as the relationship between an employee and a supervisor. So you already know that recursive relationship means what it is. So same okay relation or table you are relating twice here. Once in the role of the employee and once in the role of the supervisor. But here you are relating the employee table twice here. So such type of the relationship what we call as a recursive relationship here. So for those recursive relationship, if you are apply the any of the operation, those operations what we call as a recursive closure operation. Let's see one example. Now this is the one query. I want to retrieve okay SSN of all employees who directly supervised by the employee whose name is James Bird. Okay, so now what is the condition as I told earlier? So if it is a query is there, first you have to concentrate on what? First you have to concentrate on condition. What is the condition here? They given the name of the employee. So name of the employee in the employee table, it is stored in the form of what? F name and the L name. So that's why which operator you require now? You require the sigma operator, and you specify the condition F name equal to James and L name equal to 1. And here this is of the type string type. As I told earlier, if it is the tuple at okay domain type, if it is the string or data type, then values you have to specify using the course here. Okay. Next, I want to extract because I want to retrieve what? SSN of the okay this particular employee. So this is your employee table, and in this table I am extracting what? Where tuple is having the F name as a James here. This tuple it extracts now. Among this tuple I want to extract only what now? I want to extract only the SSN here. Okay. So what is the result you will get now? So this Bosch SSN is what? 888665555. This is the result it stores in new relation here. Next is whether that employee, okay. So now this employee, now I am extracting SSN as a role of the employee now. Next role is what? Who directly supervised by this, okay. Now I have to extract in the role of supervisor. So this is the supervision information here. This is your SSN and this is your super SSN here. So you already know that wherever you are having this SSN, okay, those employees are supervised by this James now. So that is the thing only you are extracted here. Supervision. So now where you are having this one, no, that one you have to extract here. For extracting that, so this supervision, so here you are extracting, okay, attribute SSN and super SSN attributes, and you renamed as a SSN1 and the SSN2. Okay. So that is the result of this one. Okay, you are joining this supervision and the washroom and using the condition is what? SSN N2 equal to SSN. Where SSN2 is equal to SSN1, that you have to check here. This is your SSN N2 and this is your SSN. These two where it is equal, so that indicates what it is. That is the role of the supervisor here. Okay. That result it stores here. So these are the two employees who supervised by this James here. Okay. See here, same table. Okay, you are taking once in the roll up. This SSN is the okay attribute of which table? It is the attribute of employee table, and super SSN is also attribute of the employee table only. But SSN tells the okay employee information, and super SSN tells the supervisor information here. Okay, so this type of the relations what we call as a recursive relation. So for this one, if we are performing any operation, that we call as a recursive closure operations here. Okay, next, this is the these two employees supervised by this bot. And one more query is there, retrieve all employees supervised by Borg here. So who are the employees are supervised by Borg? Those employee information you want to retrieve now. So once again you have to take this result one retrieves what? So whoever supervised by the supervisor. And next is what? All employees who are supervised by the Borg here. So then you have to join the supervision and the result one. Condition is SSN equal to SSN, and what are the result you will get? No, that result you have to supervised by the box sub coordinates. This is what? So these are the two employees supervised by Bosch, and these are the employees who are supervised by these two employees here. Okay. So this is about what we call as a recursive closure operation. Okay. For the same relation, you are performing the different operation. So different rows based on their okay roles what they play here, employee role and the supervisor role, and based on that if you want to perform some operation, that operation what we call as a recursive closure operation. Is it clear now?